Welcome to lesson 16 of this Arduino C++ course, and today we're going to be looking at a multi-mode button. Now, what I mean by a multi-mode button is it's something you see on a lot of devices. It's where you press a button multiple times to change different functions. So instead of having to have one button for each function, the same button is used to change the mode. Let's have a look at an example because it's easier to see than to tell. So this is what's on the breadboard today. Very, very simple. 6 LEDs and a button. And if I press the button, all of the LEDs come on. Now, if I press the button again, it starts to produce a pattern of the LEDs. Press the button again, a different pattern. Yet another pattern, a random pattern, and finally the final press turns everything off. So as you can see from the example, it's a way of using the same button to allow the Arduino to do multiple things. One of the questions that's often asked is, can an Arduino run multiple programs? Well, it can only sort of be loaded with one sketch. However, that single sketch can do multiple things, and that is where something like a mode button can be very useful. So let's get started and see how this all works. First thing is, obviously, if you go to the Digital Town website, as you can see, the address is in the bottom left of the page. You will find all the circuit diagrams and resources for this particular lesson. So let's take a look at the website now. And if you're moving over there slowly, please click the like and subscribe button because it does actually help the channel. Right, let's go to the website. So this is the Digital Town site. Just go to the lessons page, scroll down through all the various lessons, and we are now down at, where are we? Lesson 16, which is the multi-mode button. Click on this image here, the circuit diagram, and it brings up a much larger version. Now, I'm not going to go into this in great detail because we've looked at running LEDs and buttons before. So a quick run through. Obviously, you've got the LEDs. I am using pins 12 down to 7 for the LEDs. Each LED has its own 330 ohm resistor. I then, from pin 3, have a connection to a button. This then has a 10k pull down resistor. The pull down resistor takes the switch down to earth so that we get a good signal, and then obviously on the other side, when the button is pressed, it's going to get 5 volts from the Arduino. The only other connection is the ground coming across and then obviously moving up onto the top rail. So the circuit itself is pretty easy to understand, especially if you've been following the course. If you do get stuck on this lesson, don't forget, there are previous lessons that all build up to this lesson today. And then the code for today is, again, just click to download. You can download the zip file and you will get all the sketches for today's lesson. Right, let's get on with some coding. So the first sketch today, as always, is a test sketch, and this is the sketch that is used to make sure all of the connections are correct. There's no point trying to write code if you haven't actually wired something up correctly, and this sketch will just check the wiring. Now we are going to use pin 3 for the button, and the LEDs are going to be on pins 7 to 12. Now, if you notice here, as always, I've created an integer for the button pin, which is pin 3. However, I've created an array for the LED pins. So the LEDs are in this array, LED pin array. It has 6 elements, and those elements are given a startup value of 7, 8, 9, 10, 11, and 12, which are the 6 pins that I have connected the LEDs to. Again, if you don't understand arrays, there are some previous lessons that will teach you about arrays, and you'll see why I've used arrays for the LEDs, because it just makes it easier to create the effects. Coming down to the setup, very simple. Start the serial monitor, print out the name of the sketch. I always do this because it helps me to remember which sketch is actually on the Arduino, which am I working on at the moment. I'm then setting the pin mode for the button as an input, and then I've created an integer q, and for q equals 0, q is smaller than 6, and that is to work through the pins. It's 0 to 6, which means there are 6 pins, because obviously we start at 0 and then we get to 5 before the for loop finishes, and it will then set each of the pins as an output. These are the LEDs, and then once they've all been written as an output, it's going to send them high so that it turns the LED on. Coming down to the main loop, very, very simple. All it's going to do is serial print the digital read value of the button pin, and that's just going to let me know if the button is connected correctly. So a very, very simple sketch, and this is just proving that our connections are correct. So I've uploaded the sketch, and obviously the LEDs have now all lit up. And if you look on the serial monitor, you'll see the 0, which is the digital read from the button pin. If I press the button, that then turns to 1. So I now know that all of the LEDs and the button are correctly connected to the Arduino. I do this at the beginning of every project, because if ever you find a problem in your project and you haven't done a test like this, you will not know if it is the code that's a problem or whether you have wired things up incorrectly. And in my experience, it's a 50-50 mix with certainly with beginners as to which is the biggest problem, the coding or the wiring. So a simple test like this gets rid of the possible problem with the wiring. So let's get on to a more complicated sketch. So here we have sketch number 2, Multimode version 2, and this is just a very basic button debouncing sketch, and all it's going to do is turn the LEDs on and off with the button. Now if you go back to the Digital Town website, if you look at lesson 5, you'll see that debouncing of buttons was covered in lesson 5. So I'm not going to go into the actual debouncing in any great detail. As always, the sketch is using current millis. All the timing in this sketch is done using millis. If you start to use delay in your code in any of the examples I am making today, you will trash the code. Get rid of delay from your code unless you're just using it in the setup for some basic setup issues while you wait for things to initialize. So we have an unsigned long that stores the value of the current time in milliseconds since the board started. Button millis, which we're going to use for the debounce, and I'm setting a debounce time of 350 milliseconds. I would sort of advise you to use a value between 250 and 500, depending how fast or slow you are at pressing buttons. I've then got a byte, and we're just going to call this the LED state. This is going to let us know if the LEDs are on or off. Once again, going into the setup, serial monitor is started up. We've then got the pin modes, just as before, except this time, obviously, I'm just setting the LEDs as an output. I'm not going to turn them on. And then we come down to the main loop. Now, the main loop is based on lesson 5, and it is a debounced button piece of code. So all we are doing is we are checking, is it time to read the button? So is current millis minus button millis greater or equal to the button timer? So that means have 350 milliseconds passed since the button was last pressed. This is just so we don't get multiple presses of the button. If that time period has passed, then we're going to read the button. And we're going to get either R0, the button is not pressed, or we're going to get a 1, the button has been pressed. And that will be stored in a byte called button state. So if button state is greater than 0, that means the button is currently being pressed. At that point, we are going to reset button millis so that the timer starts ready for the next press. And then if the current LED state is greater than 0, we're going to set it to 0. And if it's 0 already, we're going to set it to 1. So we're giving it a value of 0 or 1, and then we're going to have this for statement here that's going to write the LED state to all of the LEDs. So basically, the first time we press the button, it's going to turn the LEDs on. Press it the second time, it's going to turn the LEDs off. Very simple sketch. Let's run it. So the sketch is uploaded, and now it's just a case of press the button, LEDs come on, press the button again, and the LEDs go off. Now, obviously, at that point, I can only turn the LEDs on or off. What I cannot do is change the pattern of the LED, because LED state is sort of a 0 or a 1, has that I'm turning something on, then turning it off. If we want to, if you like, change the state of things, we cannot use an if statement in the way that is used currently. So now we're going to move on to Sketch 3. Obviously, it's got the creative name of Multimode version 3. Once again, the pins are set up in the same way. We've got the button debounce set up in the same way, except this time we've got a byte that's called button mode, and I have set a num button nodes as a variable, and it's got a value of 2. That is the maximum number of button modes in this particular sketch. Once again, the setup is identical to the last sketch. Set the button as an input, set the LEDs as an output. Right, let's get down to the main loop. Now, earlier on, I set that value of num button modes to 2. So in this sketch, we're going to have a switch statement with 2 values. And then, of course, there is the default value. So the way this sketch is going to work, once again, we're going to check the button because we've got to check that debounce. So if it's time for the button to be pressed, then we are going to make button millis equals current millis. That's resetting the timer for next time. And then we're going to increment the value of button mode. Now, that means that the first time when the sketch starts, button mode will have a value of 0. So when the button is first pressed, that value is now going to become 1. Press it again, it's going to become 2. Press it again, it's going to become 3. And at that point, this if statement will take effect, where because that value is now greater than the number of button modes, it's going to reset the button mode to 0. So it means as I press the button, it's going to go, it'll be 0, press for 1, press for 2, press it again, and it will go back to 0. Then all I've done is created a switch statement that deals with the different press modes. So as you can see, for each mode, it's going to start with the serial print. So it's going to print out mode 1, mode 2, and for the default, mode 0. For mode 1, all it's going to do is work through all the LEDs and send them all high. For mode 2, it's going to do nothing with the LEDs. It's just going to serial print mode 2. And then once we press the button again and it goes back to the default of 0, it's going to turn all the LEDs off and serial print out mode 0. Now the reason for doing it this way is within this switch statement, obviously this is very simple, it's just going to turn some LEDs on. This is just going to do a serial print statement. These could be running completely different components, so you could write whatever you want. If the code gets really complex, obviously this is very simple code. What I would tend to do is create a function in here, and I'd probably call it mode 1, another function in here, mode 2, and obviously the default, default mode, whatever. But in that way you can write some quite complex code without trying to keep it all within the main loop. So let's get this code running and we shall start to see the example of how it works. So the code is uploaded, and as we can see, it has serial printed out the title of the sketch. So now if I press the button once, obviously the LEDs come on, and we see also that mode 1 was printed out. Press the button again. This time the LEDs stay on, but we get the mode 2 from the second part of the switch statement. And then of course if I press the button again, now it goes back to mode 0, and you can see that all the LEDs switch off. So now we have a very, very simple version of using one button to do multiple things. Now for the next sketch, we're going to move past some of the limitations of this. One of the issues here is obviously we are working within the debounce code. So the switch statement is within the debounce. What we're going to do in the next sketch is break this out of that, because in the next sketch we're using different timers to do the different LED patterns. Therefore we don't want that being limited by being within the debounce button function. Right, so here we are, Multimode version 4, and this is going to overcome the limitations of the previous sketch. Everything here is the same down to button mode. The difference here is in this sketch we're going to have 5 different modes, and then I also have a timer for the LED. So I've got LED millis, I've got the LED timer, and I've also got an LED counter. Setup just the same as in the previous sketches, so let's come down to the main loop. So looking at the main loop, unlike the previous sketch, I still have the button debounce. This time, just as in the last sketch, as we press the button mode is incremented until it gets to greater than the number of button modes, which now is moved to 5, at which point it's going to go back to 0. A couple of little things I've added in for testing is it's going to serial print the mode, if you like, the word mode, and then it's going to serial print the current button mode so that I can see what's going on. And every time the mode is changed, it turns off all of the LEDs ready for the next effect. There's also an LED counter that is reset to 0 because some of the effects will use this counter. Now, outside of this debounce statement, we've then got this switch statement for the different modes. And again, very simple. I've kept mode 1 the same, turn all the LEDs on. If it is mode 2, then it is using a timer, and I've got the LED timer set to 500, half a second, and it will work through the LEDs one at a time. So it turns all of the LEDs off, and then one LED is turned on, and the value of the LED counter is changed. And the idea of that, if I bring in the image, is it's going to work through the different LEDs, turning one on after another while all the others are turned off. Now for mode 3, it's going to move faster. This time it's going to work through the LEDs, turning them on one after another, but it's not going to turn the old LED off until we've lit up all 6 LEDs, at which point it will then send all 6 of the LEDs low. For mode 4, what is it doing here? It is changing 2 LEDs at a time. So what it's going to do is change the 2 end LEDs are going to light up, then the next 2, and then the middle 2. And once all the LEDs are lit, it's going to turn them off again. So if you like, a different pattern. And then finally for mode 5, it is going to pick a random LED at a random time, and it's just going to keep turning all, so it'll turn all the LEDs off, it'll turn one LED on, and it will be a random LED. 06 means that the random value will actually be picked between 0 and 5, and I've got a random value for the timer between 0 and 500, so it'll just create a bouncing effect of the LED. And then of course the default mode is turn everything off. So let's turn this sketch on and get it running. So the sketch is now uploaded, and let's go and look at our different case statements. So obviously at the moment we are in mode 0. Press the button. Mode 1, as we can see bottom left on the serial monitor, and all the LEDs come on. That is this piece of code here. Now if we come to mode 2, press the button again. This time we have this situation where it's turning off all the LEDs and then turning on the next one in the sequence. Coming down to mode 3, we get this situation where it's working faster because we've changed the LED timer value, and this time it is incrementing the LED that it's turning on until that value gets greater than 7, at which point it turns everything off again. Coming down to mode 4, this is that one where it lights the LEDs 2 at a time, starting from the opposite ends to create the effect. And finally, case 5, we have that random period that the LED is not only picking a random LED, but keeping it on for a random period of time. And then finally, of course, press it again, and we go to mode 0 and everything is turned off. Now, the important part about today's lesson is not, if you like, the different ways of flashing 6 LEDs on and off. What I want you to try and grasp is how you can use a single button to change the mode to do different things with the same Arduino without having to upload a different sketch. So we could press for mode 1 and it might take a temperature reading. We might press mode 2 and it could move a motor. Mode 3 could be moving some LEDs. Mode 4 could be using a screen. But it's that bit where each button press can be used to do a different thing within the code, allowing you a lot more flexibility without the need to have it lots and lots of buttons attached to your Arduino. Now again, as I said in the previous sketch, when you're doing this, if I was writing this for myself, and this code would probably start to become more complex if you were doing lots of stuff, you would write your own function call it mode 2 and put this code within that function. So within the switch statement, you just have call function mode 1, mode 2, mode 3, and your functions with all the code would be stored elsewhere. So that is how to use a single button to create and, if you like, start up different modes on a single Arduino. I hope that one's been useful to you. It was one of those things. I've had a couple of people this week talking about modes, so I thought, well, it's time to do a video on that, and I'm trying to work through the backlog now of other requests that have come through. So I hope that's been useful, and if it has, please click the like and subscribe, because it really does help the channel. And I'll see you in the next video. Bye for now.